Okay, let's start. I will show you the Moodle page. I yesterday, or was it day before yesterday, I put there some material for trigonometry. Here there is a lesson notes which are made by Pasi Mikkonen and Tommi Ylimäki, who are teachers who have earlier taught this course. And Pasi Mikkonen nowadays still teaches this course for Finnish students. I will not go exactly in the same order or exactly the same material as they have done, but I put that material also in this my Moodle page because I have got permission to do that, but I suggest you to read them and study with them that material also. I put there these memory rules we had last time. I also found that from one of my books, which in first time in my life I actually understand how intelligent, how wise is it to use this kind of memory rule, especially if you are good in English. So it is very easy if you just only remember this word. So it is very easy to remember how to calculate these sine, cosine, and tangent in a right angle triangle. It is correct that it would be somehow possible to find out the same kind of rules for Finnish language, for example, for Finnish language, but that is a little bit harder because, for example, in Finnish, opposite is vastainen and hypotenuse is hypotenusa. So there will be S and V and H. So it is hard to. Well, we have one Polish in this class, and in Polish language there are many consonants. Yeah. Very.
Not that.
Yeah, not that much, not that bad. Yeah. Because I always remember when I saw Polish athletes, they always had this C, Z, S, hardly, almost impossible to pronounce for a Finn. Yeah, but of course in Finnish language we also have hard words. But this is good that you reminded me about this rule. Maybe you were used of this rule already. And then I put this material. I don't know if you have had time to read these already. There is this trigonometry in oblique triangles, which would actually say in other words it would be said that these rules in this page, they hold in every triangle. So this strange word oblique, I don't know how to pronounce it. Is it oblique? I don't know. Yes, in Finnish we call those vinokulmaiset kolmiot. Vino is what is the? It not right like this. It is not in the vertical position, but somehow like this. It's called vino. For example, the wall is vino, so it is not straight wall. Vinokulmainen means that the angles are not in a right angle. But this could be also said that these are rules that holds in every possible triangle. But of course, if the triangle is right angled, so it is more easy to use this Pythagorean theorem or this rule as was told, so kahtoa, as in Finnish would say that. But you may test these sine rules or cosine rules. If you test them in a right angle triangle, so they will get you the right answer. And I won't go through these rules in from this theoretical material. I will take an example where we will use these. And I have done some examples here, but I don't like going through ready examples in the Moodle. You may watch them, but I would like you to give me a problem to solve. So let's make a wrong page. Let's make a problem where we know 3 parts of an oblique triangle. You may choose which one we know. A, B, C, alpha, beta, gamma. Just tell me. Like a random. A, B, beta. Okay. Beta. Yes, in Finnish. Yes. Example. So this is not the same example as in the Moodle. Was it A, B, and beta? A, B, and beta. Oh, sorry, you can't see this. I will draw the triangle after we get the values of these. How long is A? Let's not use units at all, only simple numbers, so we don't have to use those meters or centimeters or millimeters there, but only simple numbers. 74. It's okay. Yeah, you would like to get some more hard one. Yeah, this is okay. How about B? Sorry. 32. And what about angle? 65 degrees. No, this is too hard for an example.
Maybe simple maths.
This is when I ask students to give values for the problem or state the problem, I get this feeling what is to sit in the place of students, because now I have a problem which I haven't thought in my brains myself, so I'm in the zero knowledge at this point. First, I would like to draw a picture of that. Sorry, let's put that so that we can see. This boat. No, it is not so easy. Let's have this. A and B, 65. So maybe it's easier to start with the angle 65 degrees. I will try to draw almost in exact scale in this picture. So 65 degrees would be, if this is the one side, so 65 degrees would be something like this. And if this is beta, so B should be here in the opposite of that. So maybe I will make this problem so that the A is this side here and B is this side here, and I would draw A which is 74 millimeters and B should be. This is good point because maybe we have problems here. But let's not draw a picture at all. Let's draw some kind of picture. It doesn't have to be that kind of triangle, but for example, like this. And I will choose that. Well, A is this, and B is this, and C is this. So beta must be this angle here. Let's see what happens. 2 and A equals 74. What is 65 in Finnish? 65 if you drop the I away. How about 32? 32. And this 74, yes. You are very good in Finnish almost at this point already. Yeah. I'm very glad that I made that dictionary there in the Excel format, and some of you have, or you or in the online group have already filled that Excel sheet there, and there are words in, I think, Bengal language and Urdu and Turkish and was it Nepali language? Yeah. It is so nice to see that in my eyes, if I watch those words there, I see some similarity between, for example, Nepal and was it Urdu or Bengal language. I think they are related languages. Some words are almost the same. Okay. Now we should what to do. We have here one angle and two sides. Yes, the sine rule is it one possibility. We watch here. Sine rule is capable for solving parts of triangle if we know 3 parts of the triangle, and we found one equation in which there are only one unknown. For example, this equation here, or this equation here, or then the first one here equals the third one here. I can paint that, but it means that this left hand side equals the right hand side here. So there are possible to write 3 equations from this rule. Same holds in the cosine rule. There are 3 possibilities. And if we found only one unknown in one equation, so we can solve something from that. And in this sine rule, if we state it in words, it means that the ratio, when you divide the length of the side by sinus of the angle, which is opposite of that side, for example, A divided by sine alpha or sine big A, large A. It is always the constant. So if you divide these A divided by sine alpha, it gets the same result as, for example, B divided by sine B beta or C divided by sine gamma. So in this case, we have this triangle where we may use sine rule. Good morning. We have A and we have B and beta, so we may calculate alpha from this triangle. So sine rule says that A divided by sine alpha equals B divided by sine beta. In my examples in Moodle, here I have used these big, large letters. What is the word in English? Capital. Yeah, yes. For my language knowledge, I would thought that, for example, Helsinki is capital of Finland. So I don't know if it's exactly the same word. As you see in these examples, I use these bigger letters here. But in this case, I have alpha, beta, and gamma. So I wanted to do materials for both those who are used to these Greek letters and for them who are used to those capital letters. And we know A, B, and beta and want to solve alpha. What do we do? Cross multiplication would be, yeah. And now the unknown is this alpha here, so I prefer to multiply these first. The same order is not important, but in this problem it is more easier to get the unknown in the left hand side. B times sine alpha equals A times sine beta. Sometimes the sine rule is also written in this format, so you get one side here and the opposite angle in the end of the equation. So if there is B here or B here, there is beta in the end of the equation. And in this between part, there are alpha and the opposite side are. Sometimes in some books of formulas, there may be this kind of equations in the place of sine rule or the law of the sines. In Finnish, by the way, sine rule, it is sinilause. So this is, yes, this lause is in mathematics, it is theorem. So this is sine theorem in Finnish. And then we want to find out what is the alpha, so we divide by B. So we get sine alpha equals A times sine B divided by B. And now we have the same situation as we had in this right angle triangle in those last two problems in that test. There we wanted to find out the angle, and there we needed to use inverse function. So here we will solve the alpha by using inverse sine. And now we are able to put those numbers in this formula. (74 times sine 65 divided by 32. I had an exam before these lessons, and I have 10 calculators with me, so for students to borrow or lend. So let's calculate that. And everything looks great now, but now I put the enter, and now our problems start. On def. This is most boring first example as possible. So this means that if we get this kind of result from problem which we are solving by using these inverse functions of sine or cosine, when using inverse tangent, there will be not undefined solutions, but with sine or cosine it is possible. And do you know why? What's the problem in this?
Yes. Because it's a triangle. Here we have an angle 65.
Yeah.
And then the numbers, if you look at the numbers also.
Yes. It was impossible. I wanted to draw a picture of that triangle in the beginning of this problem, but after a while I found out that it was impossible. This angle 65 is too big for these sides of the triangle to go together in the same triangle. Or we could also say that this 32 length of B is too small or too short, so it is not possible to make a triangle of these measures. But we could see for a more mathematical reason for that. It is when we saw a more mathematical reason for this undefined result is that if we calculate what is this what will become inside of this inverse sine. I didn't do it right now. For most traditional calculator, mostly it was done so that first this number value was solved, and then after that it was pushed the button of inverse sine. And this traditional calculator mostly we saw what it was the problem. I will try to calculate it with. No, this is not. This is more traditional calculator. This probably is my son's calculator, which he got from comprehensive school, and he should have returned it to school after he gone through that comprehensive school. But it is nowadays in my calculator. I'm not sure if I feel bad. I should. 74 times 65 sine equals, and then we divide by. No, there's some problems I made not correct. 65 sine times 74 equals, and then we divide by 32. Mostly you have to do in steps in this old calculator, and this is the problem. This solution for this undefined result was that this will become inverse sine of 2.09, etc. And this is problem because this sine is a function which gets values which are between -1 and +1. It is not possible to get a value -5 or +2. So here is the problem, and this always tells that we have a starting values of the problem which are in which there are some errors, so that it is not possible to make a triangle with them. So here we see the reason for that. The sine alpha should be between +1 and -1. So here we get undefined value.
I'm going to put it in a picture form. If you are going to draw a circle in this, for example, if you're going to put it in a, let's say, a graph form, that is where we can see the picture.
Yeah.
So it means if you have anything which is, if you have two sides, and if these two sides are reducing, it cannot be minus, it cannot be below or after 0. So that's the point. So if it is going towards 0, the length is reducing until where it's going to be a straight line. So going after the straight line is the minus sign.
Yeah.
Yes.
Yeah. These are actually in triangle. These are not these values in the this -1 and +1. It is not possible to have in right angle triangle or in any triangle at all. For example, if I take inverse sine of exactly 1, it becomes 90 degrees. And if you think, for example, right angle triangle, so this means that well, if you have sine of the angle is 1, exactly 1, and in right angle triangle the so sine is opposite divided by hypotenuse. So this means that this opposite side should be the same length as hypotenuse, and it is impossible for a right angle triangle. Yeah. But if I try to do this kind of example, if I have this exactly 1 there. Right, and I will dot and 0, 0, 0, 0 and 1. So this is only a little bit larger than 1, and it is undefined. And the same holds if I put a little bit smaller than -1 there. Undefined. But -1 is okay, it gives minus 90. Well, in triangles this is impossible. There will be no minus signed angles there, but in some kind of trigonometric equations it is possible. Of course, the angle, for example, if you have some kind of rotation motion, so it starts with the angle 0 and then it's going 90 degrees, 180, and going to 360, and then goes the next round and round. So it may be whatever the angle, and if we go in the opposite direction, it will be -90 degrees, -180 degrees, and etc. So for example, in rotation motion, it is possible to have any angles. For example, in sine or cosine. But for a triangle, it is not possible. So this means that it is not impossible. It is not possible to draw a triangle stated in the problem. We found this also. Yes, it doesn't exist. Yeah. We could also use cosine formula for this.
We use another numbers that can be exist.
Yeah. We will take an example. All the triangles are not always impossible triangles. But we could also use law of cosines or cosine rule. If we watch these rules here, and we have A, B, and beta. So this is the middle one is the equation where here we have A, B, and beta, and the only unknown is C. So we could also choose this cosine equation there. So let's take that. We should get the same result, but let's see what happens there. If we use cosine rule, or law of cosines, in Finnish it is cosinilause, the same logic than in sinilause here, cosine theorem in Finnish. And there we will get This cosine rule always has the same idea. In the beginning of that cosine rule or the cosine equation, there is always some kind of part with looks a little bit similar as Pythagorean theorem. For example, the last one here, this is exactly the same as Pythagorean theorem in right angled triangles. So there are all these two letters, see A, B, C. One of those letters is in the left-hand side, and other letters are in the right-hand side, and they are squared. So, for example, if we get A squared in the beginning of the formula, so then we will have B squared and C squared in the other side of the equation. And if we get B squared, so in the left-hand side, so there will be A squared and C squared in the right-hand side, and of course this C squared, A squared, B squared also. And always cosine rule starts and ends with the same letter. So if there is A in the left-hand side, the last letter is also A, but in Greek form, so it is alpha. And we have B in the left-hand side, so there is beta, Greek version of B letter, beta, and then C and gamma. Yeah. So let's take the second version of that cosine rule. B squared equals, so I start with B, so I will write A squared plus C squared. And then I had that minus part there, so there will be minus always 2, and then the same letters then are already in the right hand side in square form. Here we have B and C, and here we have also B and C. Here is A and C, and here are also A and C. A, B, A, B. So it is quite easy to remember how to write this cosine rule. So now I have done this some kind of Pythagorean version first, and then I will put minus 2 times A times C. And then, because this is cosine rule, we use cosine of the angle, which is the same letter as here. Here is B, so it must be beta here. And now we have situation where we know B, A, and beta. So only one which we do not know is C. But the problem is that C is in the 2 places there in this equation. Here it is squared, C squared, and here it is without any power or exponent. So there is second degree term of C and one first degree term of C. How do we solve this kind of problem? Well, maybe I will. Well, let's take a book of formula, and this is sad that in these books of formulas, usually in this case we use the same letters in the equation as is stated in cosine rule or for example cosine rule or sine rule. We have second degree equation here, or quadratic equation, C squared and C. So it is not possible to just move the c in the left hand side of the equation, because there are two c's there and in different form. So we can't solve this traditionally like we did, for example, here. We try to get the alpha in the left hand side of the equation. This is not possible now. But we have to solve c here. C is unknown in this equation. So if we get an equation where there are second order terms of unknown, so mostly we have to use equation to solve that. So here we can see toisen asteen yhtälö. Yhtälö is equation, aste is degree. It doesn't mean the angle here, but the degree in other meaning. And toisen means the second. The second order, it should be probably translated in English, the second order equation. It means the equation where there are exponent or power of 2 in the unknown. But the sad thing is that in this formula we use the same letters A, B, C as we use in this equation, and they mean not the same. It is sad thing. But mostly I think almost every formula book used the same letters in this example, in second order equation. It would quadratic equation or second order equation. In Finnish it is toisen asteen yhtälö. Toinen, yes, it is the second in Finnish.
Why is that?
Yes, it is hard to. It is maybe you should translate this. It is of the second order in exact translation. So that gives this toisen. Is it? I think it's genitive. Yeah. Many times in Finnish, is it genitive? How do you say genitive? What is that? I don't know the grammar, but yeah, it is a case. Yeah. For example, I, minä, it means me, but my, we say minun. The end of n means that it's mine, minun, sinun, your, hänen, his or her, our, genitive, our, meidän, your in plural, it's teidän, and yeah. Yes, and it means this, that we have an equation a times x squared plus b times x plus c equals 0. How many of you remember the solving equation of this kind of equation? Somehow, yes, but of course we have these formula books there. So here it is said that if we have this kind of equation or equation that can be written in this form, so the solving you get by using this formula.
It's okay to use those. What is this book?
This book.
Yes. How's it called? Like you have all the rules and such in the equation.
Kaavakirja, this
yes.
in Finnish.
Okay to use during exams.
Yes, it is. Mostly our students buy this formula book, but there are also many other ones. Formula book, this kaavasto. Kaava is formula. Kaava. And in this case, the kaavasto means that it is a book of formulas. That's kaavasto.
Oh, it's STO.
Yeah.
Is what?
I actually don't know the reason for this, but for example, if there is, what is another example? For example, library. It is kirjasto. There are books in the building, so it is kirja. Kirja is book, and kirjasto is the place where there are books, library.
Okay, this is a place for formula.
Puisto, park. It is place where there are trees. Puu is tree, and puisto is the place where there are trees.
So
This technique, it means technology. So this is a formula book for technology. Tekniikka. And the solution of this problem is x equals minus p. This is as I said, it is quite easy to start remembering if you use this formula a lot, but if you don't use so just took it from some book, so it is written there. Just check one thing. I open the Word. Yeah. It takes a while.
And speaking of exams, when do we have
What?
when we have exams? If we have to have exams.
Actually, I don't know of the other courses. I think you will have in the I think is it week 43 or when we start the second term.
So late. So
Yes, but yes, and there I think I'm not sure if you both there are both two groups in this class. So one group they will have a mechanic course, but I'm not sure if they use this book there or do they have some kind of formula sheet or what they use in exams. I'm not sure. I guess it depends of the teacher.
It's a good book to have.
Yes, and these books actually these you may find from some Tori place or some internet stores there, and very cheap ones. And the year of the book is not so important. For example, this is from the year 2001, and the book has been the same after that and also before that. I have at my home the book which has the same name or same title, and it was made by Tammer Tekniikka, and it was published, I think, 1985 or something, and it was almost similar. The formulas there were exactly same, I would say. So you don't have to buy a new one. Those old ones are okay also.
Actually, there isn't one thousand.
Is there?
There is one from Kuopio, 15
Aha.
euros.
How about 15?
Yeah.
Yeah.
But 3 is like 30 euros. New one.
Yeah.
Like 30.
Yeah, I would say about 30 euros. But if you have old formula books from your old schools, it is also possible to use those.
Station. Yeah.
Let's continue. We got this equation here, and we will use it soon when we get this problem in that form that it is useful to use this formula. So I will put the numbers in our in the place of the equation there. We had b, which was 32 squared equals a was 74. C was unknown here. Minus 2 times 74 times C times cosine 65 degrees. I will quickly calculate with my calculator these square forms there. In this part, I will show in the camera also. I will calculate this last part here so that I will leave the C in the end of the expression. So I will multiply 2, 74 and cosine 65. And of course this minus sign there also. 2 times 74 times cosine 65. I will not write the whole number there, but only some decimals of the beginning of it. And then we have times C there. And after this, we notice that this is second order equation. So most useful it is to solve so that we will move everything to the left hand side or everything to the right hand side. And in this point it is easier to move everything to the right hand side because we only have to move this 1000 here. So it is a little bit easier to do so. Let's do that. So we will move this in the right hand side. So there will be only 0 in the left hand side. And then I will write this equation. I will try to write it in this form as here. So the second order term, so it is only this here, c squared and after that the first order term also, or that where there is only this unknown without exponent or without power. So in this case it is this last part of here. So there will be minus 62 point. You don't actually need to use all those decimals, but I will write them in the picture or in the paper. And then we have this 5,000 here and 1,000 here, so I will move this, so this will change the sign, so I will subtract 5476 minus 1024. So I will get plus 4,452. How do you say this number in Finnish? Joo. Kyllä. Neljätuhatta 450 2, and it is the one word 4,450 or 5/10 and 2. And right now we have the equation which is in this form here, or in well not in the exact same form, because we have 0 in the left hand side, but we could write this also in opposite order. So the important thing is that there is 0 in the either side of the equation. So now we have this second order expression here, and it is written like here like this here. So we have a in front of that unknown, which is squared. So in this case, what is the value of a in this our problem? What? 1. Yeah. In the solution formula, a equals 1. How about b? Yeah. So b means in this formula it is the coefficient coefficient or factor of that unknown which has not power. So this is simple x here, and the number in front of it is called b in this formula. So in this case it is minus. This has to be remembered that there is also this minus sign there. So the b will mean this part here. And then C, this is sad thing that in this formula, this C means the this part where there are no x, so this is the constant. I guess the name of the C comes from the word constant. By the way, constant equal is the same in Finnish as vakio. Vakio. It means vakio means in Finnish something that has the same value in every time. It's vakio. for example, temperature stays. For example, in laboratory, you keep the temperature in the same value. So it is the vakiolämpötila.
So what about after the decimal point? How do you read it in Finnish? Is it the same like those coordinates?
In Finnish, we mostly use this comma, and we call it the desimaali pilkku. Pilkku is pilkku, and then this is called piste. Is it dot? Do you use dot? Yeah. Desimaali pilkku. Then if we use this dot, it's the same word but desimaali piste.
So how do you call the numbers after the decimal point? Do you have the base for an individual number or do you have the system? The numbers after the point.
Yes.
How do you call them?
I would say this ensimmäinen desimaali, first decimal, and toinen desimaali, second decimal.
Okay, can you call the numbers for us?
If I read this number, I would say, yes, that's a good point. Yes. I would say it is 23,46. Yeah, I would say it's so.
Yeah, because in English, after the point, you have to say 4, 6, 3.
Yeah.
You read them as they are.
Yeah.
That's what I want to know.
Yeah. Well, actually, I think most official way would be the same in Finnish also. 23,46. Yes. But many times we only say that 46,46. Or if we have this decimal dot there, so we would say 23 piste 46 or 46.
Because in English you cannot call it that way. After the point you have to call it individual names.
Yeah, I guess so, yeah. This C here, so it was this constant term for in this equation. It was that part where there are no x's after that number. So here we have this constant value there, 4, 4, 5, 2. So now I would like show the same time or maybe now we have some possibilities to see everything all the time. So here we have the solution formula there. So we have here a division line here and minus b. So it will be plus. So we could think that this minus here means that it is the changing of the sign. So if we have here minus, it will be plus here. If we have here plus, so it will be minus. So it is the opposite sign. So in this case, I will write this exactly how in this formula it is written. There is minus sign there, and after that there is this b. So I will put these brackets there. So it would be like this. And then we have plus minus, so it means we have two solutions, plus or minus. Do you remember the name of this sign? Juuri, yes, or neliöjuuri. In this case it is square root, so it is neliöjuuri. Most usual mistake which is done when using this formula comes right after the root sign. So if you get incorrect answer, or many times if you get some kind of error or undef from your calculator, many times it's because this mistake I may do now. I made a mistake there, but what was my mistake? Brackets, yeah, because this formula says that this b should be squared, so whole number of b should be squared. So this minus is also in front of b. So we should use brackets here or parentheses. Remember brackets in Finnish. Do you remember what is the remember in Finnish? Muistaa. Muista. Sulut. Or sulkeet also. I use mostly this sulut, but it means sulkeet means the same. And then we have minus 4 times A. It was only 1, and C was 4, 4, 5, 2. And then we have in the bottom part of this 2 times A, so 2 times 1. Actually, in this book, and also I think many other books also, there are another formula for a case where the number in front of this squared term there is 1. So this is 1 times x squared. So then the formula would be this kind of. But actually I don't use this. I think this is some kind of old-fashioned rule, because mostly this is useful in case where you have to manage without calculator or especially without modern calculator. So it was many times important to get the equation in this form, so there will be no factors in front of this x squared there. It is always possible. For example, if we have in this formula here, for example, if we had, for example, 10 in front of this c squared, so we could divide by 10, so then we will get away from that 10. So we would get an equation where there is only one factor in front of this c squared, and then we could use this formula. But I don't see that so necessary. I think this is not so nice one. It is more easy to use this.
No, in this weird form.
Yeah.
What would it be? I can't figure this out.
Yes, in this formula. Yeah. The this B means the number in front of its x. So, for example, in our problem, the B, not the B, but B, it is this minus 62. And then in this formula, this Q, it is the constant. So it is this number here. But we would get the same result from this equation also. But I don't see it so necessary to try to remember two kinds of cases. So it is more easily to use always this, because this is more universal formula. So this, as was said, this minus changes the signs from to plus. So we could also write only this number with opposite sign there. And this part here I have to calculate. I have square root there, and I will take the calculator. This is good calculator because you can get the exact number there, so you don't have to remember the number or write it. You can pick it from earlier answers.
We have calculators in this group.
I'm not sure. Do you in physics courses? I guess you need some kind of calculators. In mechanic course, either AE or AFE group will have mechanics course after the autumn holiday. Yeah.
But that's something you get at school, like in high school, or this kind of calculator? Is it your son for this?
Yeah, or he
Borrowed it.
he borrowed it, yes, but or he didn't steal it, but he forgot to return it. Yeah, yeah. I think this is quite a cheap calculator. Maybe the price is about 10 euros. I probably guess.
I'm just asking because we don't have those. At least up in my.
Yeah. Okay. Yeah. But now we get. Or calculator got me result here minus, and I don't write the whole number there because that is enough, or actually this minus is already enough, because that tells us that there is some problem in this calculation. Remember that we had this somehow solved earlier with the help of sine rule, and we got this answer that it is not possible to draw, or this triangle does not exist. And of course we could have to get the same result with the help of cosine rule, and we get it from this, that we have a number inside of square root which is negative number. And this is always problem, because if I try to get the square root of that number, no, sorry, I have to take it different way. So I try to calculate what is square root of this negative number, and there is lots of Finnish text, and virhe means mistake or error. Ei-reaalinen tulos means non-real result, and then it is said that, for example, if your calculator or the program in this calculator is in settings where the only real numbers are available, so you can't calculate, for example, square root of -1. And then it is said that if you want to calculate with these complex numbers, so you have to change the settings, but I don't think you need those complex numbers. I'm not quite sure if you need in other studies, but mostly don't. Most probably you don't need those complex numbers or imaginary numbers. So there comes error, non-real result. So means that there is no C gets no real value, so that means that the same holds, that the triangle does not exist.
So how is Anneli not
Ei-reaalinen, for example here. Ei-reaalinen. Ei means no, and reaalinen means real. Reaalinen. Mistake, virhe is mistake. This is mistake or error. Virhe.
That's the fun.
Yes, we got 2 examples of sine rule and cosine rule in which we didn't get any results at all. But it was your fault, not mine. But when you gave me these numbers for the example, did you know already that you can't get an answer, or was it just a mistake? Yeah.
We are guessing numbers.
Yeah.
I think the best example would have been a triangle, like a scalar triangle, where we have 1, 3, and 9.
Yeah, simple. Yeah.
We could do that also.
Yeah, I think we will do, because let's take. Do we have any time anymore today? But let's start something so you get something to calculate with by your own. Let's take example 2. And I will take a triangle where there are A equals 3, B equals 5, and C equals not 4 but 6. I didn't take exactly the same example, because if we had some more realistic values for this, you could calculate it with the same way, but in this case you would get the result there. But for example, if we want to solve alpha from this equation, from this triangle, because now we know all the sides of the triangle, but not any angles. What would you use? Let's draw it first, yeah. 6, 5, 3. I'll draw the longest one with the horizontal line. 6. It is many times easiest to draw a triangle when you start with the longest side and draw that horizontal. And then we have 5. I don't have the compass in compass. Does this mean also the
Device, yes.
yes, which knows where is the north is?
Yes.
Northern, yeah. But compass is also this where with help with you can draw.
The one that you draw
Circles.
Yeah.
Yeah.
What is the name?
Harppi.
Harp.
Harppi.
Nice. Harp.
This is this compass. With this I mean this kind of device where there are north, south, east, west compass. And this is how you draw it. Something like this. I'm not I'm not architect, I'm only a mathematics teacher. Yeah. Here I should need that to draw a better drawing, but I try to use my ruler here, 5 here. I try to draw some kind of circle there. So there would be the circle there, and 4 would be there, so it will be there. Sorry, it was 3.
Yeah.
Yeah, let's continue it. 3 would be about there. It looks like a right angle triangle, but it will not be. Maybe my drawing is not so exact, but now we need to calculate the alpha. So it will be there in the opposite of A side. And now if we start with sine rule or law of sines, this is not helpful, because when you use these equations or formulas, you need to know at least one angle. So it is not no use to use these. But here we know all sides of the angle, so we may calculate whatever angle we like. And for example, now we want to calculate the alpha, so we will pick the first one here. Cosine rule. A squared, and again, if I go this step by steps, I have A here in the left hand side, so I will get the other letters in the right hand side squared. Then I have minus sign and 2, and after that the same letters I wrote here in the right hand side, B times C. And then this is cosine rule, so I will use cosine, and angle is the same letter as here. Here it is A, so it has to be alpha here. So now we know in this equation, we know all those sides. So we know this, and we know this, and this, and this, and this. These are all known. Only unknown is this alpha there. So how do I solve this equation? I should. Okay.
This cosine inverse.
In the steps, what do I do first? It is possible, but I will do that later. Let's solve with this letter equation. The first step is to find out that we want to solve this part. So let's leave this in the right hand side and leave these other b squared and c squared other side of the equation. Of course, you could also do it the opposite way, that you would move this part in the left hand side. It maybe would be better, because then we would get rid of that minus sign. But sometimes you have no time to think carefully enough. And now what will I do when I want to solve the cosine alpha? Yeah, we divide by this here. So let's divide by minus 2bc. And that equals cosine alpha. And we need to solve the alpha, so we need to get that inverse cosine. Now it is maybe good to write this equation in other direction. So alpha equals inverse cosine of that division part in the left hand side. And after that we may put the numbers there. By the way, one thing to point is that in this example we had this C was 6, it was the biggest of the or longest of the sides of the triangle, but not necessarily. Only in right angle triangle the C is always the longest side of that triangle, but in these universal triangles or oblique triangles, C may be longest one or the shortest one or the middle one. It is the name of the side does not tell anything about the side, length of the side. But many times if you have many times it is somehow when you know all the lengths of the sides of the triangle, it is maybe useful to use some kind of order there. So maybe it's good to get the biggest value for C, but it is not necessary. So here 3 squared minus 5 squared minus 6 squared. So you could calculate first the value of this expression here inside the inverse cosine, but with the modern calculators you don't necessarily have to. You may use the inverse cosine immediately and just write the numbers inside of it. You save one step off by doing this. So there are my numbers, and this calculator tries to give the exact result, but mostly we don't want that kind of result. We want the decimal answer. We have in this calculator there is this approximately sign there with the red letter, with the red color. So I will get this control with this red, and here control enter, and now I get the decimal value. In this example, we may think that these numbers are exact numbers. This is quite boring exercise if we think that, for example, these are meters and these numbers are, or lengths of sides are rounded to whole number in meters. So 3, 5, and 6. And if we are fundamentals in mathematics or physics, we would think that these are only in the precision of one number. So in that case, we should think that in the result, in the value of angle, if we round that, we should also use only one number, the precision. But that is quite boring, because one number is this here, and then we have to round it to tens, so it will be 30 degrees, the result. But many times if we have this kind of mathematical examples, we think that this is an exact number, so this is 3.0000, etc. So then we have get the value of this. And of course, if in the problem it is stated that you have to round it, for example, to 4 decimal accuracy, so it will be, I will write this in 4 decimal accuracy like this. But this is not necessarily the case. In civil engineering calculations, many times the angles are rounded to 4 decimals, but it is only a habit in that area. But in this problem, it was actually not said what should be the precision of the answers. Well, I think our time has gone to the end, so thank you for today, and I will try to put there some exercises more to the Moodle quite soon, but I don't know when.
Sorry, with regards to this formula, from the formula there where we have cosine of x. So most of the time I always make this mistake by making alpha as the subject of the formula. So if you approach it from that, you will miss the inverse of cosine. That is what I always have that problem.
Can you show more exactly? Can you write, for example, or show here?
From here, if you move this equation, and if you make this the subject of the formula,
Yeah.
and then you have it here.
Yeah.
So this is what you will miss, because I always miss this.
Okay, you only get alpha.
Yeah,
there.
I always get it wrong, because from here I make this the subject of the formula
Yeah, yeah,
straight away.
yeah,
So instead of this, I always have this here.
yeah, yeah,
Yeah, so this is, because this should be this over this
yeah, yeah,
from here.
yeah. So
If you see my point.
to remember to use
remember
this.
that, yes.
Yeah, to remember to use this minus sign here or
Yes.
inverse cosine. Maybe it's easy to remember that the unit of the angle is many times this degree, which is like a power here or exponent. So when you are solving the angle, so you use the cosine or sine or tangent with the inverse, where you use this some kind of exponent here. Yeah.
Oh, okay.
Joo, thank you. Kiitos, kiitos.